Thanks very much for that. Although I'm afraid the biggest part of the entertainment of the evening will be that since this is the premier speaker working on this new technology, and I've had one dry run, I think we may have a glitch or two. So we have a couple of questions. What have we learned in 20 or 30 years from when we had pretty good ideas? I think the simplest thing to say, and I'll show you examples of it, is that back then, it was largely theoretical. We knew that adding greenhouse gases traps heat in the atmosphere, and you can't add several watts of energy over every square meter of the Earth with no effect. We didn't know how much. And we were just starting to see the records looking like this was not just an accident. But in the last 20 years, what's really happened that's changed it and made this much more of a household conversation is that nature has been, unfortunately, cooperating with theory, and a lot of the things that were projected as plausible can now actually be observed. So I'll spend some time on that. And then we might also ask the question, why, if we knew 20 years ago that this was not only possible but emerging, and we knew pretty much what we needed to do about it, namely try to regulate the use of the atmosphere as an unpriced sewer to dump our smokestack and tailpipe wastes, as well as the effluents that come out of deforested and altered lands. Why didn't we do it? And that, of course, is not a physics or a chemistry or a biology problem. That's very much of a social science problem. And it has to do with the fact that societies are structured with interests. These interests, when they are producing products and activities that improve the quality of life of people, and I would never deny that, are very well entrenched. And then when it starts becoming clear that the things that we do to improve our quality of life start at the back end to accumulate in a way that might actually reduce it, you now run into amazing conflict between those who want to preserve the status quo, basically because either they have a vested interest in it or they think, well, it works, so it might continue to work, and those who say, no, we can't take major risks with the planetary life support system, we have to change the status quo onto a whole new way of doing things, and then obviously you're going to run into what is not science anymore, but into political battles over values. So I'll try to outline that for you. It'll be unfortunately very rapid, and we'll be able to have, I think, some conversation for a while at the end. And I appreciate your coming out to discuss this, and as well as the audiences out there watching on the web. It's just phenomenal that we can, and I've done this many times now, that we can multiply the size of audiences this way with a very low carbon footprint relative if everybody tried to fly in here. Okay, so of course they could fly in, but then they wouldn't be able to get from the traffic from the airport to here, but that's another story. So if people want to know more about this, I have a website, climatechangeoneword.net, where there's a lot more details. So I'll apologize for going quickly, but if we want to cover the broad range of issues, there won't be time to do any one of them in any great depth. I'd rather give you a sketch. And then also on that website, there's lots of guidance to other people who will amplify on various points, including people who don't agree with it, and all of that is there, and we'll talk about that. So the first question that I like to ask audiences is the science of global warming settled? I like to ask that to audiences because it's the question I'm asked all the time by media, by members of Congress. I mean, I will talk in a lot of groups, and it's fun to do a poll because when I do a poll, I just did one in New Zealand, which has very, very strong public consciousness on this problem. And I said, how many think the science is settled? And about 75% put their hands up. How many think it's not? About 25%. Now, if I did the same thing in Oklahoma, the 25 and the 75 would reverse, you know, and California is sort of in the middle, more on the side of people being concerned about the problem. So that tells you about their perception, because people's actions and behavior, which needs to change, depends on their perceptions. So first you've got to find out what they're perceiving. But my favorite thing when I kind of do that survey with audiences, I don't know how that would work on a sphere, but is to ask people after they say, is it settled? Yes, no. And then how many think, I'll ask you guys this, it's a stupid question. That's right, because we're talking about complex science, and in complex science there are, as the slide shows, well-established components where we know things sometimes even beyond a reasonable doubt. There are components with competing explanations where we've been able to narrow it down to 2 or 3 possibilities, and then there are components that are speculative. So what you end up finding out in the complication that you see out there in the quote real world, that place that we all live in sometimes, is that we find that there are those coming from, say, a deep ecology group who will be grabbing the well-established components with the most nasty outcomes and present us with those. It's not illegitimate to do that, but they'll tend to focus on that. And then you get somebody from an enterprise institute who focuses on the speculative or even things that are beneficial. They'll say, well, CO2, we call it life. It's plant food. And indeed it is plant food. It makes green things grow more. It also happens to make weeds grow more, and it acidifies the oceans, threatening the base of the food chain. This will come out to later. So weighing these things is all part of it, but you get this parade out there in the, quote, real world of sort of the end of the world and the good for you extremes, and I'll confess my prejudice. Those are the 2 lowest probability outcomes. IPCC said that warming of the Earth since 1850 is unequivocal, and this is the unequivocal. It's about 1.4 degrees Fahrenheit, 0.75 or so degrees Celsius, warming since then in 2 pulses, one up to 1940s, a slight cooling after then, and then a major rewarming since the 1970s. And that is unequivocal. How do they know? Thermometers, not just that, melting glaciers, I'll show you an example or two, rising sea levels, all consistent. And if you bring the ecologists into the act, plants are blooming earlier in the spring and birds coming back earlier from migration. Now, the vast bulk of nature is not observed, so what you do is you observe what you can. It's work that my wife Terry Root does and other colleagues, Mike Mastandrea and I worked on this. And what we tried to do is ask that question as to whether it was unusual, and of those species showing change, about 80% change in the direction you'd expect. That is, having spring earlier and moving north or up mountains. So all of these things taken together led IPCC to use that unusual word, unequivocal. So clearly that's in the well-established category. And here you can actually see the seasonal rotation of temperature, and it's also showing you as it gets longer and longer that actually if you take a look at the amount of red, it's a lot more in recent decades than it was before. So when climate scientists talk about these things, they never pay attention to what happens in 1 or 2 years, which is certainly not true in a lot of op-eds in the newspapers. Oh, but it was a really cold winter, what a joke that global warming is, while neglecting the fact that it's been a vast increase in the number of extreme heat waves and only a few record cold. So you have to do your statistics right. And that, unfortunately, doesn't work well in sound bites. So this is also in the same Intergovernmental Panel on Climate Change report, and it shows a clear trend of decreasing snow cover in the Northern Hemisphere. But if you picked any 20-year block there, you could say, oh my God, if you look from 1960 to 1975, it looks like it's getting cold. And then if you look from 1975 to 1990, it looks like we're going to hell in a handbasket. And these are what I like to call false trends. And we have another problem, which is that the world of climate is a world of decades, at least 20 to 30 year long trends, and the confidence that you have is much greater when you're looking at global to hemispheric to continental scale. So what we know the least about is short-term, time-evolving trends in precipitation in neighborhoods, regions, states. But then the world of political science, as my political science colleagues, I call this the first law of political science, which is that all politics is local. And I would add a lemma and short term. So you have a big mismatch between political attention and many stakeholders' attention and the nature of the confident problem that the scientists have. Now, the large-scale changes that we observe will translate down locally, but they're going to gather, quote, noise, that is, become less in the short run clear until you wait long enough to see it. So all of that helps to complicate the issue. Well, one thing that people do is they look at glaciers in mountains. This is a Patagonian photograph glacier somewhere around 1930, and you've all seen these before and after pictures. So the next picture is exactly the same spot. So if you look at the mountains in the background and just try to remember them for a second, this is what it looked like about 8 or 10 years ago. It's radically different. Now, did I cherry pick this to pick the worst case? Not even remotely, because what IPCC does is called meta-analysis. You can't learn anything from looking at one glacier. And there are people who actually, I hesitate to say polemicize, but that's what it is, who find the 5% of glaciers that have been advancing, mostly due to shifts in circulation that brings in more moisture, and then saying we have just falsified global warming as a global trend, which they haven't at all. That would be falsifying Ronald Reagan's electoral victory in 1984 because he didn't carry Washington, D.C. and Massachusetts. So that's why we look for preponderance. And what we have to do is convince the public not to be bamboozled by fraudulent arguments about local exceptions to overall preponderance, because the basis in system science is not everything lines up. It's preponderance of evidence based upon an evaluation not just of the amount of evidence, but also the quality of the evidence. And that's precisely what the IPCC, the U.S. National Research Council, the Australian Commonwealth Scientific and Industrial Research Organizations, the British Hadley Center, there's a German one, I won't give you the whole long litany, but they all do the same thing independently because every country is suspicious of something international and they all have basically the same conclusions when they look at that data. And therefore, a lot of people in science are just continuously rolling their eyeballs when they start seeing these op-eds about how it's not true because somebody is citing the small fraction of evidence that doesn't agree and then saying that that refutes the basic overall preponderance. And when you start fighting with the media about that, what you hear is, but we have to be balanced. And I'll say, what paradigm is that? Well, it's the paradigm of honest reporting. Get the Democrat, get the Republican. And in covering two-party politics, they're right. But when you cover science, it's not two conclusions. It's multiple conclusions, and there's relative credibility on each of these conclusions. If you don't report that, then you're formulaically following a very bad idea and misleading the public on what the scientific community knows. And that's another reason that underlies the long delays that we've had in getting people willing to get on board the issue in terms of understanding, because they hear so much cacophony from some people with PhDs. Well, one of the most important things is sea level. Now you can all see what a great graphic artist I am on PowerPoint. That red thing, you all know what that is, right? That's 747. And we're flying up there at 70 degrees north, and this is exactly what we saw when we were up there, which is actually what the Greenland ice sheet looks like. Now, all the water that's up on Greenland accumulated in the form of ice is enough to raise the sea level something like 7 meters if it melted. And 125,000 years ago, the sea levels in the world were 4 to 6 meters higher, and most of Greenland was melted. By the way, it happened to have been 1 to 2 degrees warmer then. Now, that doesn't prove that if we warmed up 1 to 2 degrees now that we would melt it the same way, because it was a different cause. It was a change in the orbital elements, the angle of the Earth to the orbit. You know how tropics of Cancer and Capricorn are 23 and is it 1/4 degrees? Well, back then it was 24.5. That meant more sunlight coming into the high latitudes, and we could actually explain why it was warmer back then. In fact, we use the same computer models we use to project the future to explain the past, and when they do, your confidence in them goes up. There are people who say, oh no, you can't use those models because that was different cause. In fact, when you have the same model with the same underlying principles, you drive it with different causes, and you explain different phenomena, you should only increase your confidence. It doesn't mean you're certain, but it means your confidence gets higher. That's how the community works. So anyhow, if you look at that ice sheet, you can see at the lower part, that tongue, that's called an ice stream. It's a very fast-moving area, and when that landed ice ends up in the ocean, in this case the Davis Strait, it's a rise in sea level. And it's been predicted for a long time, and it happens even without global warming, that the edges of that ice sheet melt. But up on the top, the part to the upper right, if you warm up the atmosphere, it holds more moisture, you're actually going to increase the amount of snowfall and decrease the sea level. So who wins? Well, you can't tell by knowing one goes up and one goes down. You have to use what we now have, which is very exacting satellite measurements, where they actually do a very careful study of the gravity, because you can monitor the satellite's orbit very precisely. You can actually figure out the change in gravity from the Greenland ice sheet, which disturbs the satellite's orbit ever so slightly, but within the detectable limit. And from that, you can actually figure out what we now know, which is that the melt rates are much, much faster than the accumulation on the top. Yet I still read in op-ed page, articles in the editorial pages of the Wall Street Journal that we've refuted global warming is melting the ice sheet because the ice is increasing on the top of the ice sheet, exactly as the forecast has always said it would. The issue is a matter of the relative rates, and it's very tough to get this kind of problem to be intelligently perceived by the public unless they hear the wide range of things, and that's so difficult to do in the soundbite system that we're stuck in, and why education is so critical, and why this institution here has such an important role to serve in dealing with these questions. The other thing is, if you looked at that, you would see that there are little tiny dots that you can hardly see there. Yeah, and let me just stop it there for a second. Those dots are those little blue things. What those are meltwater lakes. They're all over Greenland now. And those meltwater lakes, what do they do with the water? It doesn't just sit there. Well, it runs in those little moulins, as they're called, which I used to jokingly say during the last presidential campaign is something that I'm sure that the governor of Alaska would well understand. They're rivers to nowhere. And the real question is, where are they going? And I think the next one will show that. And it'll show up by itself, I think. Or do I push? There we go. I told you I'd have glitches. Okay, so we hold this for 1 sec. That's a river nowhere. It's going down. And now, this is critical, because if the water goes all the way to the bottom and starts lubricating the ice sheet and increasing its capacity to slip, plus water is at 0 C, and the ice down there is much colder than that, and it starts to melt the bottom, and then it slips, just take your hands and rub them over each other. You can feel the heat. That's going to cause more liquid, which then is what we call a positive or amplifying feedback, and it could lead to a, quote, tipping point. If you warm up enough to get enough meltwater down, could you create an unstoppable, irreversible deglaciation of Greenland? When I say irreversible, I'm talking about on a human civilization timescale, 10,000 years, like we had 125,000 years ago, and then it grew back, of course. But that's pretty long. From our perspective, that's irreversible enough. And of course, this would redraw the maps of the world where more than 50% of people are living within 2 meters of sea level. This would not be a good thing. Problem is, how long is it going to take? Well, we don't know. Are we talking centuries, millennia? And at the moment, all we can say is that there's a risk of meters of sea level rise in centuries to millennia. But it really matters. We're asked by governments all the time, so what is the threshold of the tipping point? How much longer do we have? How many more degrees can we warm up before we do this? We don't know whether the water is reaching the bottom. There's competing explanations. Some people say, well, it's just refreezing in the middle. Others say it's going to the bottom when we're approaching a tipping point. So good science tries to measure. So they go out there and they lower cameras down and they get them down a few hundred feet, but this thing goes down thousands of feet. So the cameras get stuck on ledges and the water keeps disappearing. So finally, NASA came up with a really brilliant high-tech solution, which was deployed this year. And if you look at those carefully, you can see these phone numbers. So if they actually start showing up in the fjord at the bottom end of the Jakobshavn ice sheet, then we'll know that they're going through. Or if somebody starts carving out the belly of the beluga and they find them, you got to call NASA and tell them. The problem is if it takes 50 years to get there and it's too late, we have a real problem, and this is where we're going to have continuous problems, which is how much certainty do you need before you start hedging against a potential irreversible significant outcome? That is not science. That's value judgments about your degree of risk aversion and how important it is to you to continue to use the resources we now have that are limited on a variety of human improvements, or whether we want to prevent a potential catastrophic outcome that would be a legacy that we'd be leaving to posterity. So you have, on the one hand, a number of my economist friends saying, well, if we spend too much money now, we're depriving the future of a legacy of wealth and infrastructure. And we then say, but if we don't do something now, we're leaving them a legacy of biotic impoverishment and non-sustainable environment. And then my economist friends, I'm stereotyping because not all say this at all, nor do all environmentalists say what I said, but the typical answer is, but if they have the money, they'll figure out what to do about it. So we end up with a very, very different paradigm between those who believe that if you're rich, you can substitute for anything, including nature services and the height of the sea level and species, and others who say, no, we're not going to figure out how to invent our way out of the problem, so therefore we better prevent it. And those different viewpoints govern the degree to which people are willing to make current investments as a hedge against these longer-term issues, which is why, cute as the rubber duckies may be, it's very important to try to get some scientific basis on the seriousness of the tipping point, whether it's like my colleague Jim Hansen in NASA says, 1 degree warming, Celsius, and we're going to disintegrate Greenland ice sheet. I'm actually more pessimistic than Jim. I would argue that what you've already seen gives me a few percent unnervous probability that it's already too late. At 1 degree, my guess is 25% chance. At 2 degrees, 60% chance. 3 degrees, 90%. Now, those numbers aren't science because we haven't lived in the future yet. We have no way to determine that directly. So what we have to do is build models of the process. We have to make measurements to validate the models, and we have to get groups together because one person's probability is not anything anyone should go on. You have to look at a whole range, and that's why we have IPCC and National Research Council, and why we don't generally ask governments and individuals to make judgments about risk. Risk is what can happen multiplied times its probability. What to do about that is risk management. That's every citizen's job. Through the representative government, hopefully they're carrying out your values. So there's plenty of work for us and plenty of work for everybody else once they understand what the risks are. And what scientists do is they're perpetually revising their estimates of risk by going out there and gathering more data. You know, if we start seeing these ducks, we're going to be really a lot more concerned than otherwise. And if you don't, it doesn't mean that it isn't real. They may just be getting trapped in crevices too. All of that is part of what the research establishment does. Let's move on now. So there's a picture, if we hold just for a sec, on the left, and this was actually in Al Gore's movie. He didn't draw it, he just borrowed it from the community archives of where the melt was on the coastlines of Greenland, where the ice sheet is lower and it's warmer near the oceans, while the ice was building up in the top, and there it is in 2002. That's a dramatic change. Remember I said there are competing explanations? Here's another one. Dynamical meteorologists say, well, this could just be an internal oscillation of the North Atlantic climate system, just a change in how the jet stream waves are. And that could be. Others say, no, this is too dramatic, it's got to be global warming. Well, how can you answer that question? It could be either one. So you could say, well, if it's 50% chance of global warming, 50% to redraw the coastlines of the world, maybe that's too high an odds. Let's hedge. Others say, no, let's get more information to be sure. That's back again to this value judgment about where your risk aversion is. So let's move on now and say, how can you try to figure this out? Do I push it or do you push it? All right, let me try. Okay, so let's go to a town right there. You can see the sea ice, by the way, fluctuating around from one year to the next. That's the summer sea ice. And you'll notice as it comes and goes that this climate system is very noisy. Remember I said you have to have 30 years, 20, 30 years of data before you can see a trend? Watch it later on. Let's just back up 1 second, if we can back up one slide. Thank you. I circled Ilulissat, which is a very interesting town because that town is right at the outlet of the fastest moving ice stream in the world, the Jakobshavn, coming out. And when those icebergs get out there, their sea level rise. They're not just making, folklore about ships that went too fast without lifeboats. So let's go on and take a look. So my wife and I, next one now. We're in Ilulissat, which is behind us, and there's Terry Root, and we actually had a very interesting time meeting with elders, and we went out there into the channel, and in the next one we'll do that. Well, when we get to the next one, it'll do that. Let me try this. Did we do that at the same time? Yeah, there it is. That's the town. Whoops. Can we back up? Am I going too fast? All right. So there's the town of Ilulissat, and you can see that big snow-capped ridge behind it. Looks like those major mountains. Well, guess what those are? They're not mountains. They're icebergs. And they are really quite massive. And the next picture shows the town. See, there you can see the town and the icebergs from the position I'm looking at it now. And in the next one, so we rented a little fishing boat, and I tried very hard not to think about the Titanic as we were banging into these little icebergs. That iceberg is right in front of the town. And it's melting, of course, because the water is warm enough to melt, that the water is over freezing. And this is rising sea level. Of course, once the iceberg's out there, it's done all the sea level rise it's going to do. Once it gets out there and the melt just increases it. So let me move on here. And yeah, you do it. Thanks. So we go out there. These are what you see when you get out there. They're just absolutely amazing. This was one of the icebergs that actually, if you look at it carefully, it doesn't look like the, remember icebergs, you only see the tip? Turned out that the bottom erodes because it's in the water and the water is warm, and eventually it gets unstable and it flips over. And you do not want to be near it when it flips over unless you like 10-foot local tsunamis. And when you're in a fishing boat, that always made me a little nervous. But we got close to that one. It had already done its flip. And about 5 miles later, the next one just blew me away because when you look at it, this one, I didn't have an actual measurement. We were estimating it 1,000 feet high because the ice was discharging for thousands of years into the ocean by going through a 100-mile-long channel. And it was grounded on that channel, and then it discharged at the edge where Ilulissat was. Well, that was in 1850. By 1950, it had backed up halfway down the channel, and between 1990 and now, it's gone right back to the continental margin. So what's happening is, that's why you can have such a massive iceberg, because it's now moved into where the ice is very high, and now there's water which can calve it faster. So the question is, how fast can this happen? Well, people have estimated the maximum rate that Greenland would be able to add sea level would be 1.5 meters in 100 years. But in 200 years, which is certainly the lifetime of cities and ports, we could be talking several meters. And inexorably committed to maybe more than that. That's why knowing the tipping point is so critical, but we have to be honest and say we are very confident there's a tipping point. We just don't know exactly where it is. We're back into risk management, gambling with the planet. And that's where the decisions have to be made. Next. And just a few more lovely pictures. It was sunset, and some of these, even though these are sea level rise, and they make me, when I think about what they mean, get worried, but they are absolutely gorgeous. And another one as the sun went down, and then finally, because we can't spend too much time on this, I want to bore you with a few graphs. As the sun set there, it really is quite beautiful and spectacular, but the meaning is not always happy. So here's a picture that we should stop at for a second, because what we're looking at here is we're looking at the most recent picture of Greenland. Now, do you notice the melt, the pink? That's even substantially more in 2005. It's been a very, very rapid rate of decrease. And when you take a look at that, you start to think, wait a minute, is this really a natural internal fluctuation? You still can't tell until you look at the red dots, which Connie Stefan, who's a very fine glaciologist, University of Colorado, the red dots where he went and he sampled the snow layers back in time, because there are annual snow layers you can count for 1,000 years, and they're the first recorded snowmelt. You cannot tell me that this is a 50-year fluctuation if you don't see any melting for hundreds and hundreds of years. I'm starting to tip my belief away from competing explanations toward getting well established that this is related to global warming. I'm not 100% there yet, because we still have more evidence to gather. And remember again, the political judgment is at what level of certainty do you require before you want to hedge against this? And that depends upon the consequences and what you can do about it. All right, let's go on now. All right, this is another very important issue. The black line is the sea surface temperatures in the North Atlantic. The dashed line is an indicator of the last 40 years, 30 years of the, no, excuse me, since 1930. It's only the last 30 years it's been really up there. You're going to hold that for a second. Let me, if it'll go back. And what that is a PDI, that's the dashed line, right? That's called a power dissipation index. It's how wide the storm is multiplied times the cube of the wind speed. Why the cube of the wind speed? Because energy is U squared, and power is the time rate of change of that, which is U cubed. So this tells you how strong the storms are. And there's a dramatic increase. Well, competing explanations. North Atlantic Ocean, just fluctuating around, very noisy system. So what did a good scientist do? In this case, Kerry Emanuel from MIT. He took a look in the Indian Ocean and the Pacific and saw not quite as good a correlation, but a very similar pattern. That's not too likely to be due to North Atlantic internal dynamics of the climate system. So what we do is we sidle up to the degree of confidence we can have by trying multiple sets of experiments and looking for consistent patterns. Nobody is going to claim that this is the truth, and IPCC said it's more likely than not, which is exactly what preponderance means, which is what it takes to get convicted in a civil trial. It's more likely than not that the increase in power density is due, at least in part, to the warming of the ocean temperatures associated with global warming. What causes hurricane intensity is very complex. It's multiple factors. Nobody's claimed the number will increase or anything of that kind, just that when you have a really strong one, warmer water will probably make it stronger, and that's actually been observed, but it's still a very noisy system. This is very consequential for the world. And you can see there storm systems, and sometimes you'll see a hurricane blasting out of Hurricane Alley. Okay, let me move on now. How much of this is due to us and how much is Mother Nature? Well, we've detected a trend. What this shows is that the trend has been upwardly sloping. That is predicted by computer models. Is that proof? No. Could be circumstantial. But it's what we call a fingerprint. But there are many fingerprints. The stratosphere cooled. The lower atmosphere warmed. If the sun did it, as is so often asserted by the critics of overall mainstream global warming ideas, then it would have warmed the stratosphere in the middle of the lower atmosphere and the surface. That's not what happened. Does that absolutely prove that the sun didn't do it, or that it was global warming due to human activities? No, because if you're completely ignorant, you got a 50% chance the stratosphere warms, a 50% chance it cools. You got a 50% chance the lower atmosphere warms, 50% chance it cools, so you got a 25% chance it's random by itself. It's a preponderance, but it's not enough. But you put that together with the previous one, and then you ask the models, and what happens in the middle of continents? Models say warms up more than middle of oceans. Did that happen? Yes. Another 25% coincidence. If models say lower latitude continents warm up less than higher. Did that happen? Yes. By the time you're finished, the preponderance is so overwhelming that IPCC said it's very likely, more than 9 out of 10 chances, that at least the last 50 years are driven by human activities, using the atmosphere as a free dump for our wastes. And that's what's been motivating all the talk about climate policy. That does not mean all the details, like how will rain change in Kansas. We don't even know the sign. So what do we do about it? Well, here's an insurance company that has to, the reinsurance company, that has to pay to the damages of the 50,000 people who died in the super Euro heat wave in '03, or the Katrina victims, or the fire victims in Australia or in the US. and they think this is dangerous, certainly to their stockholders. And just as the coal industry thinks that climate policy is dangerous to their stockholders. And we have $2 trillion groups in each other's face. And that's what our political system is supposed to adjudicate. Well, where'd the word dangerous come from? We can hold this for a sec. This is, I promise you, I will not read it, just the red. Stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic, means we did it, interference with the climate system. This is the law of the land. This was signed by President Bush, that is Bush the first, in 1992 after the Rio meeting, and was ratified by the U.S. Senate. So we are committed to this, as are about 190 other countries. It's one of the 2 or 3 most signed treaties in the world. And this law of the land says that we should not warm up so fast that we cannot have ecosystems adapt naturally to climate change, or have food production disrupted, or have economic development disrupted. Well, clearly, if you're a small island state and you're flooded out, your economic development is disrupted. But if you're China and India and you're counting on using coal as the cheapest available means to develop, then your economic system might be disrupted by climate policy, which raises the price of dumping CO2 in the atmosphere. Now you have a problem of trade-offs, completely different perceptions, a whole different host of people who are harmed either by the policy or by the others, and that requires international negotiations where people are willing to give something to get something. In order to do that, you have to have compromise. In order to have compromise, you have to understand the position of the other person and have some trust. I'm sorry to say that up until now, the U.S. had no moral leadership on this problem. That is radically changed. And I think we'll be reading in the newspapers, especially the Copenhagen meeting in December, that there will be a lot of world effort to try to deal with the problem, but we still will have to deal with the question of the development of China and India and Indonesia and Brazil and Mexico, who want to dump more in the atmosphere, and they claim that they have a right to because per capita, we're 5 times more emitting than they are, and we use the Victorian Industrial Revolution with sweatshops and coal burning and internal combustion engines to get rich, and now we've concocted this new block called global warming to stop them from following suit. So we say, you guys are overpopulated. They say, you guys are over-consuming. By the way, both are right. And they point the fingers at each other. That's not going to work. We have to have a deal. We have to have compromise. We have to share the development of alternative technologies. We have to invent our way out of the problem by providing incentives to companies. I don't want the government inventing technology. They're not good at that. But the government is the only group that can provide incentives to try to encourage corporate investment. And I got asked by a member of Congress not long ago, well, how much do you think we'd need in loan guarantees to venture capitalists, to the 100 best startups on solar, thermal, and safer nuclear, and smart grids? And I said, I don't know, out of my head, $40 billion. He said, are you crazy? $40 billion in this current economic time? And I said, didn't you guys just spend, and I'm talking about $40 billion a year for, say, 10 or some odd years to get them over the hump. And I said, didn't you guys just spend $1 trillion of our money in 1 year to bail out a bunch of underregulated, greedy bankers? And you're not going to spend 5% of that for 10 years for planetary sustainability and sustainable jobs? I mean, come on, we have to look at these problems holistically and over time. That's the kind of issue you're going to hear increasingly on this debate as it switches off from the science side to the management questions, which are not about risk, what can happen, what are the odds, but risk management, what do we do about it with a world of limited resources and very differential sets of winners and losers. So, the characterization of the climate problem, oops, we can just back that up, thanks, is, yeah, can you go back this one, is, I think the slide says it, no, that's too far, is, it was the, just go, that's it. Potential for significant risks, nobody denies that. Deep uncertainties, anybody who denies that doesn't understand the problem or is spinning for some interest. Normative judgments, which means value judgments, and I've given you a lot of examples about how you have to make trade-offs and you have to weigh incommensurates. Optimal solutions, economists love optimality. You can't optimize because in order to optimize, you have to dollarize everything. How do you dollarize the benefits of the shipping industry of shorter routes across the Arctic as the Arctic sea ice is melting away very rapidly now versus the destruction of the polar bear ecosystem or the Inuit hunting culture? Those are not dollarizable. And do you discount the Greenland ice sheet at the cost of money? I mean, these are issues that require political decisions. Then, once you've got targets, now you bring the economists in to do cost effectiveness, because it's completely stupid to waste money. You want to achieve the target that's politically negotiated, not economically negotiated. Costs matter, but that's not cost-benefit analysis with cost effectiveness. So there's plenty of room for everybody, and we all have to understand these, and that's what a risk management framework is. Okay, I have a couple of minutes. Let me finish. So let's talk a little bit about something that's not typically valued. This is a sky island in New Mexico and Arizona. There are many of them. They stick up, if you fly over the Nevada and Arizona, New Mexico, you can see these things. And they go from the desert between them, and then it gets green at the top because they're high enough that it's cool enough that you have vegetation. Well, guess where there are more species? Down on the hot sand or up there on the top? And if the next one shows that, it's actually the slide from Terry Root. And if you just look at the gray bars on this one, that's the number of endangered plants and animals on the Sky Islands, if you just hold it for a sec. And the other bars are all the other ecosystems in the area. So it's dominant. But if you warm up, the species want to rise up the hill, but they've run out of room. So now we're threatened with what IPCC said was something between 20 and 30% of species facing extinction if we warm up somewhere between, in Fahrenheit, like 2 and 4, which seems to be right on the trajectory that we're headed toward 2050, let alone the much more than that toward the end of the century if we stay on the pathway we're on. So the question is, do we care? What can you do about it? Next one. So just getting into California, there's a, oh, I'll come back to that. Let's stay with this. So let's take a fast look. Oops, what happened? Keep going, please. There we are. That's called a rock rabbit. It's pika. Anybody ever seen them hiking up there? They're really cute little things. It's a rabbit. They like warrens, but the warrens, they don't dig in the rocks. The rocks become their dens. And in 1900, they were located an average back up. But they were They were located at 7,800 feet, and in 2004 they went up because it's been warming. So is it going to go extinct? Probably. Unless we move it. That's called managed relocation. So you can move it to save it, but if you move it, it now becomes an invasive species in a taller mountain or one further to the north. So what's the worst evil, moving it or letting it go extinct? And when people say, oh, what a choice, what a horrible set of decisions. Yes, it's a horrible set of decisions, but they're forced on us because we keep changing the system. So one thing you might say is, well, instead of making this decision, why don't we decide to charge people for dumping their wastes in the atmosphere? And maybe we wouldn't push the system so hard to threaten these awful choices. And these are where you start getting different perspectives together. Okay, let me see where we are, because I need to wind up. So here's what we need. Dealing with ecology, you need habitat restoration, reserves, migration corridors, and yes, we have to consider these awful trade-offs that are very normative. So let me stop the slides there and just basically conclude that what we're really doing is we're trying to identify on the science side where the primary thresholds are where we have to be really concerned about local systems and sectors and groups. If you look at the Euro heat wave in 2003 that killed 50,000 people, they weren't poor, they were elderly. They were living in walk-up apartments in Paris that were actually fairly fancy. If you look at Katrina, where 1,000 people died, they mostly were poor. If you look at diarrheal diseases in the developing world due to a combination of poverty, and as you get hotter and you reduce food production, that largely falls on children. So we not only have to take a look at the aggregate, we have to take a look at the special vulnerable groups, and we need to do two things at once. We have to have an adaptation strategy to deal with those changes that are in the pipeline that we're not going to mitigate. But as we start defining the thresholds, and they're somewhere between now and a few degrees when they really accumulate, and we've got to mitigate to prevent that from happening. Currently, it's not a pretty picture. There's a fan of uncertainty, human behavior, low emissions, medium and high. Except for this year, after the economic problem, we have been actually emitting in the last 10 years above the highest IPCC scenario. We're toward tripling of CO2 unless we do something. And therefore, that's a scenario where almost everybody who studies this is very concerned about those impacts. So we have to find a way to help protect those people who are going to be harmed by that which we cannot mitigate, because even if tomorrow we had the greatest breakthrough in the price of solar thermal machines, we wouldn't be able to implement them in terms of replacing the vast bulk of our fossil fuels in under a generation and a half. So we're going to have to be committing to some overshoot change. But let's make that overshoot as low as we can, as soon as we can, and get off it as fast as we can. And that's where we're going to have what I call this learning by doing feeding frenzy, where we come up with incentives to help where our industrial system is so effective, which is inventing our way out of problems and get a return on investment, but you can't get a return on investment until you have an investment. And that's where we're going to need public-private partnerships to help stimulate that investment. And sooner or later, we have to have a price on carbon. You cannot continue to dump there without a cost, because if you do that, then you send the wrong market signals to people about which directions we ought to go. And that's where you'll be watching the national and the world debate very acutely in the next 5 years. Thank you very much for listening. Hold that. We might get to this. Back one more. That's it. Stop. That's geoengineering. That's number 5. This was my suggested policy sequence. Let me go in order quickly. I love questions that let me finish my talk. And so the first I've already told you, adaptation to changes in the pipeline. The second, performance standards. California has 50% of the emissions per capita, the energy use per capita, as the United States, and is more than, and is a whole third again better than Texas. Why? Because California has a 35-year history of building codes, performance standards on air conditioners and other things, now tailpipe emissions, which Detroit, after 4 attempts to sue us, have lost, and we're about to get the Obama administration's approval for Fran Pavley's bill. These performance standards are often the cheapest, most cost-effective way to make a difference. The problem is you can't just have California and Oregon and Washington and New York and Pennsylvania and Massachusetts and New Jersey doing it. You've got to get the whole country. So we're going to need to make them mandatory. That's going to be an interesting filibuster fight, and that's coming. Second is the second is public-private partnerships. I've talked about those. The third is the shadow price on carbon, like a cap and trade or a carbon tax. I've talked about that. The fifth is your question. I put it because it makes me very nervous. If there is about advertent modification like dust in the stratosphere and so forth. So you have to make sure that you don't overreact. So you'd have to do it slowly. But I think that's the easier problem. I think that technically, over the time frame of decades, we'll be able to pin that down moderately well. The question is a social management question. Who are we going to trust to throw dust in the stratosphere for the next 500 years, which is how long it takes for the CO2 and the climate in the system to hang around? And Susan Solomon just said 1,000 recently. Is that right, Mike? Or at least 1,000. So we'll have to have a cadre of climate controllers in place through wars, hot and cold, through malevolence, malfeasance, and all kinds of other problems, misjudgment. And who's going to be responsible if there are really bad, negative environmental fluctuations, weather or climate fluctuations, which we may have had nothing to do with, but you could not prove either way? So in order for geoengineering to work, we'll first have to solve the social political problem of deciding who in the world do we trust to determine how we modify the climate. My own view is, if you have a heroin addict, it's much, much smarter to try to get them in the hospital, go cold turkey, then get the therapy so you don't go back on the street, and then try to rebuild their lives. On the other hand, if all that fails, well, methadone is probably better than heroin. I view geoengineering in the planetary methadone category. It's the last resort if we are absolutely incapable of solving the problem the right way. And unfortunately, I have to agree with my colleagues who say we'd better do the research, because if it turns out that we're on the unlucky side of the uncertainty curve, you know, the bell curve's right-hand tail, then we could have sufficiently catastrophic outcomes that we might, just like the managed relocation choices that we hate, that we might have to consider, we might have to consider geoengineering on the backside of the century if we've really been unable to do due diligence through changing our behavior. So let's wait and see, let's study it, but if we don't study the component of management, then we'll actually be missing what I think is its most problematic aspect. So it's a very good question. And expect it to go on a lot more than people have heard to date, because a lot of people involved and worried about costs and maintenance of certain industries would love to have a technological fix that will put us out of increasing the price of conventional energy, which then moves away from them toward the renewables, and we're going to see all sorts of interests on this, so stay tuned for that debate too. Okay, a good question. I was actually asked that question by Congressman Rohrabacher. Oh, the question was, has there been very much climate change in the last 10 years, and warming, that is. And in fact, you didn't give the full account that I got from him, which is, well, the witnesses from the IPCC, this was a year or so ago, and he said, has CO2 been increasing since 1998? And everybody said, yes, it has. Has temperature been increasing? And the answer to that is a little bit, but not nearly at the rate of the previous 20 years. And he said, therefore, I have falsified global warming. I said, no, Congressman, you have done nothing other than show that you don't understand the difference between signal and noise. I was nicer than that, but I shouldn't have been. And the reason for that is, if I had gone from 1992 to 2000, it would have been warming up at 3 times the average of the last 30 years. And now if you go from 1998, which was the largest El Nino in the planet's modern history, we don't know what happened before we were measuring it, which leads to a natural fluctuation on warm. It hasn't warmed up that much since then, and that's all part of what we call climatic noise. Nobody in climate, remember I said earlier, we're talking 20 to 30 year minimum lengths, would ever claim that radical warming from 92 to 2000 proved anything any more than the 98 till now relatively mild warming proves anything. You have to hang around and see, and it's almost certain it's going to go back on its standard growth curve, but we'll find out. So you have to make sure that you separate out the signal to noise. And somebody said, well, how can you explain that in English? And I said, well, let's see. I used to be a fan of Willie Mays when I was growing up, and it would be looking at 7 or 8 years of climate average, would be trying to figure out Willie Mays' batting average by seeing how he did in August of 1958. I mean, you've got to have long enough records to be able to have them have any meaning. By the way, even with the shakedown cruise, this is a very cool thing.